Welcome to this video on the basic RC circuit. In this circuit we have a voltage source, a switch, a 5K ohm resistor in series with a 200 microfarad capacitor. Initially, when this switch is closed, then the capacitor acts like a short circuit and begins to charge. Thus, for initial values, the initial voltage across the capacitor, since it is a short circuit, is 0 volts. The initial current would then be the voltage source divided by the resistance, since that's the only element initially in the circuit. So this is 10 volts divided by 5K ohms, which will equal initial charging current of 2 milliamps. As the circuit charges, as the capacitor charges, then the voltage begins to build up across the capacitor. And at t equal to 1 second, you have a certain amount of voltage. At t equal to 2 seconds, you have another amount of voltage, and it continues to charge through its charging time until it becomes fully charged or has 10 volts across it, which is the source voltage. This amount of time, these charging times, are called the time constant, and they're equal to the resistance in the circuit times the capacitance in the circuit. In our case, it's equal to 5K ohms times 200 microfarads, which tau then is 1 second. The actual charging time from 0 to 5 seconds is called the transient time, and this is equal to 5 times tau. So in our case, it's 5 times 1 second, or 5 seconds. So it takes 5 seconds, or 5 time constants, or 5 tau, for the capacitor to charge from 0 when the switch is initially closed until it reaches a full voltage. Once the capacitor has reached its final voltage, then the capacitor then acts like an open circuit, so no additional current can flow in the circuit. So that means that I sub C, or the current in the circuit, is equal to 0 amps. Since the capacitor is acting as an open circuit, then there's no voltage drop across the 5K ohm resistor. Therefore, V sub C is equal to V sub S, which is equal to 10 volts. This concludes the video on the basic capacitor analysis.